Hello and welcome to my demonstration of the project traffic in CS50AI. So let's run the script and I'll explain the functionalities in detail. As you can see, I'm running the script in a Conda environment. That's because TensorFlow doesn't have a support for M1 MacBook chips. So that's why you can simply ignore these couple of lines. The training starts from this line. So while the model trains, let me explain the functionalities of the script. So the load data function that we have, it needs to read all of the images given a data directory path. So what we want to do is make it independent of the environment. That's why the operating system library comes in handy in this situation. It allows us to read all of the directories and the files inside of these directories independently of the operating system. We need to take care of the separate operating system separators in the paths. That's why the join function comes in handy. Using the lister function, we can simply read all of the directories and get rid of this one. It's a Mac issue. And using the join function, we give the data directory and the inner directory and get the inner directory path. So using the inner directory path, again, we can iterate over all of the files inside of the inner directories. So we can then get the images path of the images given the data directory, inner directory, and the file path. We append those using the join function of the operating system and read the images using the OpenCV library's imread function given the image path. And after that, we need to resize the images as suggested using the resize function in the OpenCV library again. We give the image width and height as the parameters to the function and receive the resized image. After resizing, we append those images and labels, which are the integer representation of the directories of the images, to our list and return those as a tuple. So the second function that we have is creating the convolutional neural network and compile it and return it. So we use the TensorFlow library's keras library. The sequential function allows us to add multiple layers to our neural network, and what I have came up with in my experiments is that using two convolutional layers consecutively allow me to get much better accuracy result with decent compile time. So the input shape is important here. It is simply the image width, height, and 3 different colors. The input shape here needs to be this. Otherwise it gives an error. I've used 32 and 64 filters in my convolutional layers and add the max pooling of size 2 to 2, which allow me to get better accuracy results. So after the convolutional layers, I flatten the output and add a dropout layer in order to prevent overfitting. And to do that, I added a dense layer with 128 layers, which got me better accuracy result in my experiments. And the output layer should have number of categories, amount of units. And since it's an output layer, of course, we use the softmax activation and we compiled the model. I've used the legacy Adam optimizer. However, if you have decent support, TensorFlow support, the up-to-date optimizer should work just fine. Now let's see the accuracy results. Throughout the epochs, as you can see, the accuracy got increased from 34% to 95%, and we need to check the test accuracy. It is much better than the training result, so we are sure that we get rid of the overfitting. The accuracy is 97%, which is quite good in my opinion. I hope I explained everything clearly, and see you next time.